Okay, hi again. Last time we covered R as a calculator, and now we're going to open R again on our sidebar over here, and we're going to use it to do something a little bit different, which are create objects. And one thing I've been telling you in these videos that R is an object-based oriented programming system, and we're going to talk a little bit more about what that means. So again, we open again, and we've got our four window panes, we've got our source, our script editor here, our console, our global environment where our objects are going to be, and then our plots. So I'm going to go ahead and use my open function again here, and I'm going to go to navigate to a piece of code called R vectors. And this is going to open up a piece of code that you're also going to have access to that is going to teach us how to create vector objects. So these are kind of the lowest level objects that R deals with and that you'll be dealing with in class. And right away, we've got a comment to ourselves here on line 2. That R is an object-oriented code, which means you, quote, create objects that hold different bits of information. So this is extending the operations of R beyond just being a calculator, but we're going to hold those answers somewhere. And below is a series of operators and functions that create objects. And so I've got a little note to myself that what's going to happen here next is creating vectors. So in our last video, we were just using R as a calculator. Like we came down here and did 3 plus 5 and we got 8, or is 3 less than 9 and we got a true. But now what we want to do is actually take some time to think about how to make R really become a super calculator or a computer for us. So in line 8, we're going to see that we've got a note to ourselves that we're going to create what's called a numeric vector. So this is a series of numbers using a function, and this function is called C. And then I have a little note to myself, C question mark C. And what you'll notice is that I've got a C sitting right here, and then an open parentheses and a closed parentheses. And on the inside of those, I have a series of numbers that I've made up. 1, 2, 5.3, 6, minus 2, and 4. And so a little note to ourselves here is to say, when I say C question mark C, I can come down here, type question mark C, and it's going to bring up a help page. And this help page tells me about the function C. Well, C stands for concatenate, which means just stick together. And what C does is it combines values into a vector or a list. And this gives us a list. And on the inside of each of these functions, we give it arguments. And in this case, in our case, we're using the C function and we're passing it several different arguments. And those arguments are numbers that are separated by commas. 1, 2, 5.3, 6, minus 2, and 4. And so if we select just this portion here, C with these numbers in it, and we run that, you'll see that what's returned is those series of numbers all together. 1, 2, 5.3, 6, minus 2, and 4. And if I wanted to add a number to that, I might say comma 9 or comma 10, but I'm not going to do that. I'm going to stick with my original number, or my original list. But so far, so we've created a vector of numbers, but so what? And what we want to do in this lesson is show you how to take something like a vector or an answer to a 3 less than 9 and store that somewhere. And we're going to do that using the assignment operator. And the assignment operator is the less than minus sign right next to one another. And a way to think about it is to think of it as an arrow. So we've got something over here that we've called A1. It's just a name. And what we're going to do with A1 is, the way to see this is that whatever this function returns, we're going to stuff it into or put it into A1. And this A1 is now going to be our object, and that object is going to be this vector of numbers. And so a way to read read line 9 in regular language is that A1 is going to be filled up with or assigned a vector of numbers that's going to be the result of this function C, or concatenate. And so when I run this whole thing, select this whole thing and run it, one of the things you'll notice is that my numbers don't show up. In this case here, R is just returning me the same number of vectors again, but when I assign it to a thing called A1, it just gives me an empty caret. But when we look over here in our global environment, we see that we've created the object A1, and it tells you a little bit about it. A1 is numeric, it's a series of numbers. This bracket means that this 1:6 means it's 6 elements long, and then it gives you a list of what those elements or those numbers are. So 1, 2, 3, 4, 5, 6. And if I come down here and I type A1, now it's like I'm asking R to give me what A1 is, which is, again, a series of these numbers. You'll notice that the output of this function here, when we did C, parentheses 1, 2, 5.36 minus 2, 4, is the same as when we typed A1. And the reason why that is that we assigned the results of C1 using this assignment vector right here to this name, A1. So we've created that object. So we've stored that in memory. We can ask a couple different things about what A1 is. So here's a function called length, and you'll see the open parentheses and the closed parentheses again on either side here. In fact, you'll notice that as I mouse over this, it'll show me where my closing parentheses is, and that's one of the rules that R has, is that when you open parentheses, you got to close them on the other side, and whatever in here, this is the thing that we're going to apply this function to. So we're going to ask what the length of A1 is, and we can do the same thing. We can type $length and hit return, and you'll see that length it gives us the length of an object, right? So we want to get the length of vectors, including lists and factors, any R object. Okay, so, and you'll notice down here it usually gives down here a little bit of some examples down here that you can play with and copy and paste right into the console. But for now, we're going to work with the examples that we have up in our source code up here. So let's go ahead and run this. Length A1, that's line 10. And the answer to that is 6, because the length of this vector is 6 elements long. 1, 2, 3, 4, 5, 6. All those elements are different, but the length is 6. We can also ask what the mode of this is. This returns the mode of the object, and if we run that, the answer is that it's a number. It's numeric. It could also be logical, or a character, or something along those lines. Or we can ask what the summary of A1 is, and this is going to give us summary statistics. It's going to tell us what the minimum value is, which is -2. There it is right there. What the median value, that's the middle value, which is going to be 3 in this case. It's also going to tell us what the mean is, that's 2.717, and what the max is. And also gives us the first and third quartile, but we don't need those things right now, if hardly ever in this case. Then we're going to take a look at the table. This returns the counts of the different unique elements in the object. So if we look at our object A1, we see we have 1, 1, 1, 2, 1, 5.3, 1, 6, 1, -2, and 1, 4. And so if we run a table of this, and we run this, you'll see that's what we get. We get 1, -2, 1, 1, 1, 2, 1, 4, 1, 5.3, 1, 6. But you can imagine a vector that has 2 1s in it or 2 4s in it, and then the table would tell us how many of those unique elements are in there. We're going to work now, we're going to create another object called B, but it's going to be a character vector. And you'll notice that here we have, what have we done here? We've put numbers into the concatenate function and assigned it, but now we're going to put text, except our text here is surrounded by quotes. Quote 1, close quote, comma 2, 3, 4, 5, 6, and so on. And we can run this. And when we run that, you'll see that another object comes up over here. This is B. This is a character. CHR is short for character. It's different than a number. It's still 6 long, but it's 1, 2, 3, 4, 5, and 6. We can again type B. It will return 1, 2, 3, 4, 5, 6. And again, we can ask for the length of B, which is again 6 elements long. Now those elements happen to be text instead of numbers. Or we can ask for a table of B. How many different things are in here? Well, there's 1, 5, 1, 4, 1, 1, 1, 6, 1, 3, 1, 2. And you'll notice that up here, they're arranged alphabetically, not numerically. We can also have a logical vector. We talked about trues and falses in the last one, in the last video. Here it is. We're going to call something D, and it's going to be a series of trues and falses. This is called a logical vector, and we can run this. And again, you'll see here are the values. D, it's a logic, it's length 6, true, 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 false, true, false. We can look at D. If we just type D in, there's true, there it is down here. And we can ask for the length of D, which is again 6. And the table of D, this is going to be a little bit different. This is going to tell us it has 2 falses and 4 trues. So there's the 2 falses, here's the 4 trues. Let's try another way to do this. Here's E. Now instead of doing the concatenate function, we're just using shorthand here, this 1:6. This is the shorthand for creating a series of numbers from 1 to 6. So if we run this, if you just run the 1 to 6, and you run that, you'll get a little vector of 1 through 6, and now we're going to store that in E. I'm going to run that, and here it is. Here's an integer now. 1, 2, 3, 4, 5, and 6. And the difference between integers and numerics is that in the numerics we have decimal places, and the integers we don't. We just have whole numbers. But they can mostly be used interchangeably. Let's try something else. Here's a F, and we're going to use a function called SEQ, which stands for sequence. So if we do a question SEQ, do a return on that, we're going to do a sequence generation. And here's an example. We want to sequence from 1 to something else by so much. But here, if we go back to our simple example here, we want to go sequence. The first argument here is the from, right? So we want to go from 1, the second argument, which is down here, the second, the commas separate the arguments, from 1, comma, okay, so that's the from. The next thing is the to, so we're going to go to 6, and the by is how many steps are we going to take? We're going to go from 1 to 6 by 1. So if we run this, guess what you're going to get? F, it's going to be 1 through 6 again. And if we scroll down here, we'll see that F shows up as a number, 1, 2, 3, 4, 5, and 6. Here's G. We're now going to do something using the repeat function. Here's replicate elements of a vector. And the way to read this is I'm going to repeat. Remember the little sequence here, 1 through 4. If we just run this interior part, there it is, 1 through 4. I'm going to repeat this sequence, 1 through 4, 6 times. And so when we do that, and you run it, again, here's G coming up over here, and you'll notice now G has 1 to 24, which is good because I'm repeating something of length 4 6 times, and 6 times 4 is 24. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. What does that look like? Yes, we've repeated the sequence 1, 2, 3, 4. Here's the first 1, 2, 3, 4, 6 times. Here's the second one, here's the third one, and so on to 6. So if we do a table of G, we see that we get 6 1s, 6 2s, 6 3s, and 6 4s. We can also use the repeat function. It's almost identical, except instead of putting times in here, we're going to put each in here. So we're going to repeat each element of 1 through 4. And what do you think that looks like? We'll run that. Again, 8 shows up in our objects over here. It's 24 long, but you'll notice that it's repeating each element 6 times, 2 4s. So we're going to have 6 1s, 6 2s, 6 3s, and 6 4s. But if I do a table on this, it's going to look identical to G. There's 6 1s, just what's different is the order. So there, we've created a bunch of objects, and this function now, this ls, open parentheses, close parentheses, asks to list all the objects that we've created. This is the list of things that we've created that R knows about. It's over here on our left-hand side. There's A1, B, D, E, F, G, and H, and there we go. Now, you could see how we could create lots and lots of objects, and one of the questions that comes up is, well, how do we remove objects? And that comes here in this little piece of special code. This is the RM function. You'll notice I have it commented out here because it's a very powerful function. It will remove all the things that you've stored. Sometimes we want to do that, but a lot of times we don't want to do that. So if we come in here and we remove everything, this RM function, so remove, and RM asks for a list, and this list is going to equal the list of everything that we have. So we want to delete those things. So it's a little bit unusual, but you'll get used to typing it. This is running everything or killing everything. You'll notice as soon as we run that, everything in our environment is empty. In other words, everything that we've created is totally gone. It's gone. And so you may feel, oh, that's terrible. But what's really nice is that you've saved your code, right? You have all this up here. And so if all you do is select everything on the left-hand side that you've run and rerun it again, you'll notice that it all becomes populated again with all your objects. So save your code. You save your code, you save your project. So let's try doing some of the things we were doing with a calculator except using vectors. So here's A1 and B, and this line of code is we're going to ask to add A1 and B together. And okay, we got 1, 2, 5.36 minus 2 and 4. That's a numeric vector. And then B, what's that? That's a character vector. 1, 2, 3, 4, 5, and 6. Well, if we run this, it produces an error. It says error in A1 plus B. It says non-numeric argument to binary operator. And all that means is that you tried to take a letter and add it to a number, and that doesn't make any sense, right? And so I'm going to give you an error. I don't know what to do with that. And so what we're going to do instead is one thing you have to know is that whenever you're adding and subtracting or multiplying things together, you're going to have to make sure that you're doing it with either a numeric vector or a numeric and an integer or something that's not logical or a character vector. So let's create another one here. This is A2. This is a series of 6 numbers. We're using the concatenate again. And here's our vector. What is this? This is A2, and we've got 0.0001, 0.001, 0.01, 0.11, and 10. Some of you might recognize that as a logarithmic scale. But here it is. This is 1 e to the minus 4. And so you'll see that this is over here in scientific notation. What does this mean? This just means that we have 4 decimal points in front of our number, and minus means that it's in front of. So this is a very small number, another very small number, and then up to 10. Here's 10 e to the 1, which means that we've got one place after the 1, which is a 10. That's what we've got here. Well, what we can do is that since both of these objects are length 6, we can add them together. And so if we do A1 plus A2, you'll see that we get 1 plus 0.0001, which is 1.0001, and so on and so forth. So A1, every element in A1 got added to A2. So here's A1 plus A2, and it's the addition of these two numbers. The second element in A1 plus A2 is the addition of 2 in this number, which is 2.0010, which is great because we can run now A1 minus A2. We can do this for a full vector. So what we were doing before, which was just handwriting 5 plus 1 or 5 plus 2. Now, since we've assigned these things objects, we can do calculations on really, really big vectors. In this case, we're only doing 6, but what happens if your vector is 1,000,000, which means we can do mathematics really, really quickly. Here's A1 divided by A2. Again, these are all the arithmetic operators that we were working with before. Here's A1 times A2. Again, what are we looking at? We're looking at the first element of A1 times the second element, the first element of A1 times the first element of A2. That's what this represents, and we get 0.0001. Here's A1 raised to the power of A2, and we get that, and so on and so forth. And now we can also run our logical operators here. Is A1 less than A2? Well, you'll see that that is false, 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 and then true for the last two elements. True for the last one. So A1 is less than A2 in the last two elements, but not in the first, not in the first four elements. And we can go ahead and run those all together, and what we're doing is we're running these logical tests on every single element, comparing each element A1 and A2, just as a reminder. Here's A1, here's A2, and this line here we asked, is A1 equal to A2, and the answer was false, 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 false. None of them are exactly equal to each other. What was really interesting about having a vector like A1 is that every element occupies a little place. If you think about this as a street, right? So this is like a address, or each of these things occupies an address along this vector. This is the first element, this is the second element, this is the third, fourth, fifth, and sixth, and so on. And what we can do is ask about, we can ask A1 for a particular element. In other words, I want to say, hey, this line here, A1, I want the fifth element. This little bracket now is different. What we've done before is dealt with curly brackets, but now we're going to deal with block brackets. So the curly brackets, or the curvy ones, those were for functions. The block brackets are like for addressing. So if we say A1 bracket 5, what we're doing is we're asking for the fifth element of A1. Here's 1, 2, 3, 4, 5, and if we return that, that is -2. So what we've done is 5 now is asking, I want the fifth element, or I want the element that's at address 5 for A1. And we can ask for the first element, which is 1. We can ask for the second element, which is 2. We can ask for the third element, which is 5.3, and so on and so forth. We can also ask for more than one at a time, and that's what this line 59 does right here. We're looking for the second and fourth elements of the vector. So we're combining our concatenate function, in this case 2 and 4. We run that, that's 2 and 4 together. But if we stick it in these block brackets, what we're asking for is the second and fourth element in A1. And what would you predict that to be? Well, here's the first, here's the second element, here's the third and the fourth. So I'm predicting if I run this, I should get 2 and 6. Because in A1, the second element is 2 and the fourth element is 6. And so A1 bracket, this little index vector here now, 2 and 4, gives me, I'm saying I want the numbers that are at address 2 and 4, and that turns out to be the numbers 2 and 6. Now, there are some common functions that you can do with vectors. So let's just take a look at A2 here for a minute. This was our second vector that we were adding together. We can ask for the sum of everything that's in A2. So if I hit run, it's going to add up all the different elements inside A2 and give me the answer. That's the sum. I can ask for the minimum of A2. What's the minimum? 1e to the minus 4. Again, what's A2 again? There it is. There's 1e to the minus 4. What's the maximum? Well, the maximum is 10. How about the range? That should be two numbers. Well, it ranges from 1e to the minus 4 up to 10, right? That's what that is, 1e to the 1. How about the mean, or the average of the object? You can run that. The average of A2 is 1.85, and the median value of A2 is going to be 0.055, which is another way to look at the center value. So in this little lesson, what we did was we went through how to create a vector, how to interrogate some basic properties of vectors, and again we ran them and we discovered them over here. And then we saw that we could add or multiply vectors together to do math really quickly, and then we could query each one of these vectors using indexing. And then we can also add operators to entire vectors. We could add the sum for all these things, the minimum, and we're going to use these things in our class to try and understand some of the data that we're looking at. Next time we're going to deal not with vectors but with matrices, which adds a little bit of wrinkle to this, but we'll do that next time.